All right. So this video, of course, can also be referred back to help you study. But listen, as we're working with the limit, the overall value is what type of value at the end? Your answer is always a y value. And down below, you're given what x is getting close to. I can't stress enough that for both x and y values, you are not having exact values, you are only getting close to it. So in other words, you're saying as x is getting close to 5, what is that fraction getting close to? Now, despite my saying that x is never going to equal 5, you could, if you don't have any difficulties with continuities and so forth, plug in a 5. Now, that can seem counterintuitive. Kids will quickly point out, wait just a moment. You said x doesn't equal 5. You're only close to it. All the same, you could plug in a 5 and say, we would expect to get close to this value. So up on top, you'd have a 7. 4 times 5 is 20. 20 minus 1 is 19. Again, as x would get close to 5, this fraction, which would represent a y value on a graph, would get close to 7 over 19. Usually kids look at that and they'd say, oh, that's nice and easy. How about 1b? As x gets close to 7, what does this quantity get close to? 12. Now, someone could protest and say you're actually going to equal 12. Yeah, I guess you could make that point. But we're just saying as x gets close to 7, what's your y value getting close to? It suffices enough to say it's 12. For 2a, it's a game changer. It's a game changer. You see, I guess what I'm trying to point out to you is if I gave you this instead, imagine that I gave you f of x, and you know what? It's not a bad thing to actually even pull this off to the side and see what's going on. Let's just say that I turn on the calculator, and here we can bring this over here. We could go to y equals, clear that out. You could say I'm going to type in right up here, parentheses x plus 2. And we could very quickly plug in x minus 5. And then we come down here and we've got x plus 2. And they're saying, hey, what's happening as x gets close to negative 2? Well, my original problem was that, but I just said, what if I wanted to find f of negative 2? That is saying let x equal negative 2. All the difference in the world. Don't let x get close to negative 2. Let it truly equal that value. Well, you could go to your table if you'd like, and you see you're in trouble. If you try to plug in negative 2, guys, you get an error. Because guess what? You can't divide by 0. Although some people will try to claim Chuck Norris can't. So you're looking right here. Nobody can, right? You can't. So you've got 0. You've got 0 right here. It's not going to work. Undefined. Undefined. Now look, you look at this limit though. And kids will say, oh, that's undefined. No, you're not letting x equal negative 2. You're getting close to it. See, you're in trouble when you plug in negative 2. I think we can all agree on that. I'm going to cross out the x plus 2. Something that you can't do with 0 over 0. 0 over 0, you can't cross those out. You can only divide real numbers by themselves other than 0. As soon as you're dividing by 0, it's game over. Sometimes kids look at that and they'll be quite troubled. They'll say, now wait a minute, don't you really get 0 over 0 in the limit? Yeah, you do. 0 over 0 in a limit means further investigation is needed. 9 times out of 10, we're going to do some kind of factoring to cancel things out. And things will cancel out because you're just getting close to negative 2. You're not canceling out as 0 over 0. You're just getting pretty close to that 0 value. All the same, right now, plug in negative 2. What do you think our limit value is really going to be? Negative 7. you get negative 7. So guys, when you plug in an x value, and if you ever get 0 over 0, what that means is you need to investigate that limit further. If it's not factored, factor it out. Try to do some canceling. And very often, the factor that would cause the issue of getting a 0 will be canceled out because now you're just getting pretty close to 0 in those parentheses. You're actually a non-zero quantity. So you can cross it out. Take a look at 2b with me. I think very quickly, kids will plug in a 3. 3 to the third is 27. 27 minus 27 is 0. Down below, 3 squared is 9. 9 minus 9 is 0. Hey, this doesn't mean you don't exist. What it means is you have to look at it differently. And this is something where the denominator, I think so very often kids correctly point out that you can factor the denominator into what, by the way? X plus 3 and x minus 3. But it's the top where sometimes kids will cringe a little bit. They'll say, ooh, I think I saw this a long time ago. The difference of cubes. Will the difference of cubes factor out? Yes, I'd like to remind you of it. Difference of cubes, a cubed minus b cubed. Anybody remember? A minus b. I don't know if you had Mr. Olson. He a lot of times talks about SOP. Same, opposite, positive. That's what SOP stood for. Same, opposite, positive. Sometimes you'd say, what on earth are you talking about? Well, this. You get that minus, keep the same sign, right? That's what's going on. Next, you go to a squared, but now you're going to have to go with the opposite. You saw a minus turn it into a plus. You're going to have ab. And then you always end with a plus. We're going to end with a plus b squared. Using that principle, you can also remember how to factor a sum of cubes. Help me out. What do you think? A plus b, same. Then I'll go a squared, guess what? Minus, that's your opposite, minus ab. Then you finish with a plus b squared. Now, why do I bring that up? Well, you want to use that here because it's like x to the third minus 3 to the third. Your a is like your x, your b is pretty much represented by 3, right? So what would this factor into as we follow this formula up above? We get what? X minus 3, then what? Help me out. X squared plus what? 3x, or x times 3, then what? Plus 9. That's your a minus b, a squared plus ab, plus b squared. If your a is x, your b is 3. Follow it through. Now, when you see that, I hope you're going to say, hey, this is great. It's great because right now you're going to be able to cancel out your x minus 3. The x minus 3s are going to cancel out. That's what got you into trouble. That's what's getting close to 0 over 0. So you cancel those out, and really it's not 0 over 0 right now. It's just super close to zeros. Big difference. And now what? Well, it's just like your first problem where you could say plug in a 3. What would we get? Well, it's 3 squared plus 3 times 3 plus 9. Down below, I've got 3 plus 3. So this is 9 plus 9 plus 9. That's what? 27. 3 plus 3 is 6. You could reduce that. Divide out a 3, I take it, right? And we'd get 9 over 2. What is that fraction getting close to as x is getting close to 3? Well, 4.5, or 9 over 2. Okay, we doing okay? Take a look at part C. Sometimes kids look at that and they'll say, well, I'll plug in a 4. We all know the square root of 4 is 2. 2 minus 2 is 0. Down below, 4 minus 4 is 0. 0 over 0, again, just means Check it out, see what's happening. It doesn't necessarily mean your limit doesn't exist. You have to do some factoring or some kind of work. Sometimes kids look at this and they're like, wow, I just don't know what to do. Actually, two different things you could do, to be quite honest. Does anybody have an idea? Yeah. Well, you can't really just, you could think of this as x to a 1/2, that's true, but you can't like factor it out though. Any other ideas? What's that? Yeah, the bottom isn't x plus 2 and x minus 2, although I think you're close. Let's see, you could have a difference of squares. Andrew's saying that there's a plus 2 and a minus 2 in here. He's right, but it can't be an x and an x, because x times x would be x squared, wouldn't it? What would you have? Radical x. You see that? Sometimes kids will look at that and they'll say, what are you talking about? Well, look, if you've got a squared minus b squared, I think we all know it's a plus b times a minus b. Right? We factored that out a lot. Maybe when you first learned that, your teacher told you to just take the square root of those numbers out in front. Right? Take the square root of a squared, take the square root of b squared, and then you'd know how to factor it. Like, for example, when you had x squared minus 64, kids would say, ooh, make that x plus 8, x minus 8, because the square root of 64 is 8, right? Well, we know that the square root of 4 is 2, but then you'd have to take the square root of x also, wouldn't you? Wow. Well, does that help you? You bet it does. These would cancel out. You'd have a 1 up on top. Now you can plug your 4 in. And you'd have 1 over the square root of 4 plus 2. And the square root of 4 is just a 2 itself. 2 plus 2 is a 4. Your final answer is 1/4. Wow. All right. We doing okay with that? Okay, there is another way to do 2c, but we'll talk about that a little bit later. Let's take a look at 3a real quickly. And with 3a, there are several ways you could do this problem. Several ways you could do this problem. There's an algebraic way, a numeric way, and a graphical way. And dare I say, maybe I'll talk to you about all of them. Here's something that you need to be aware of. If I gave you the absolute value of x, would you agree that there's a piecewise definition that the absolute value of x could be x or the opposite of x? Right? And would you agree that's if x is greater than 0 or if x is less than 0? Usually kids look at that and they'll say, I believe that. Well then, what do you think the absolute value of x minus 6 would be? Sometimes kids will look at that and they're almost like, what do you mean? Well, look, the inside part is what you set up here. What's the inside part? X minus 6. Or the opposite of x minus 6. You've got one of those two extremes. What about the boundaries? What do you think we'd have here? This would be if x is greater than 6. Right? Greater than or equal to 6 if you'd like. This would be if x is less than 6. Sometimes kids will say, how is that making sense? Well, look, you're looking for the inside to be positive. The inside is positive when x is greater than 6. Do you see that? It's likewise negative when x is less than 6. So from an algebraic perspective, I'm looking at 6 with a plus. That means I'm what? Bigger or smaller than 6? It means I'm bigger. If I'm bigger than the 6, which one of the two assignments should I be looking at for this piecewise function? A or B if I'm bigger than 6? A. You see what I'm talking about? That's just going to be x